Now, of course, in real life, there are many problems that we can solve with simulation methodologies, and it is an advantageous model. And according to Pageant, there are these advantages of simulation listed as follows. For example, the new policies of a system can be explored without disrupting the real system, it says. So we are talking about the warehouse in our previous example, right? So if you intend to experiment for the benefits that you are going to create when you construct a new door into this warehouse, then implementation of this in the real system is going to create some cost, and you will also be disrupting the processes in this original system, right? I mean, in order to construct this new door, at least for some amount of time, the processes performed in the warehouse are going to be stopped for a while, okay? So basically, trying a new policy in the real system is disrupting the performance of the real system. But with simulation, you can try and see the performance effects of these changes without disrupting the real system. You can directly implement it over the model. So let's talk about another advantage. The new system design can be tested without committing resources for their acquisition. Okay, so imagine you are going to open a new warehouse or a new supermarket into your distribution network. Okay, and of course, if you want to see the real effects of this new supermarket, you need to open it. It should work for a while. The people should acknowledge this supermarket. So there will be a major demand coming to that supermarket. Okay, so you can only test the performance of it after committing some time and some resources on this new design. Okay, so we can generalize this situation to any type of new system design. For example, a physical layout of a factory. So you may think that if you change the location of the machines in a factory, basically I'm talking about changing the physical layout, you may think that you may minimize the material flows and you can increase the efficiency, but not everything is deterministic in real life, and you can only see the actual result when you really implement it, or you can try it in a simulation model, okay? Or a hardware design, or a process design, or a transportation system, especially transportation systems. For example, in public transportation, if you are going to offer a new bus line or a rail line, a new rail line, you want to see how it is going to affect the people's lives, right? So how it is going to improve the traveling times. Now you can see the improvement that it is going to create first with a simulation model without constructing the new rail system or offering the new bus line. And after seeing the performance changes that it can create, improvements that it can yield, then you can, by relying on the simulation results, you can try this new system. And there are some hypotheses that the scientists may offer in real life about how or why a certain phenomenon occur. Okay, now, for example, you see in the autumn time or the springtime, these flock of birds are flying around, creating these interesting shapes in the sky, right? So why they are doing that? This is a natural phenomenon, right? But why they are doing that? Now, you can put a hypothesis on the behavior of the flock of birds, and you can test if this hypothesis is true to explain the cause of this behavior. Okay, how you can test it? Now, by explaining the cause or explaining the individual behavior of these birds and put this behavior into a simulation model, you can see if the same kind of shapes occur in the simulation model as well. Now, if you really see if it occurs in the simulation model as well, now it is somehow getting you closer to prove your hypothesis, right? So actually there are studies like this. For example, in the evening, we know that in highways in Istanbul, there is a certain traffic congestion, right? So this is actually a phenomenon that occurs almost on every day. So we need to understand why this is happening, why we have traffic congestion. Because we have too many cars in Istanbul? Actually, that's not the reason. Okay, that's not the main reason. The main reason is not the fact that we have too many cars. The real reason of traffic congestion is the acceleration when we want to stop is a lot larger than the acceleration when we want to move. Okay, so if you want to increase the speed of automobiles from 0 kilometer per hour to, for example, 8 kilometers per hour, it takes some time to accelerate to that point. However, if you want to stop from 8 kilometers per hour speed to 0, it takes almost 3 or 4 seconds, right? So because of the differences in these accelerations, most of the traffic congestion is caused. Okay, that's not the only reason, of course. I mean, we know that there are too many automobiles in Istanbul as well, but that is one of the main reasons. So this can be proven by a simulation model, actually. What are the other advantages of simulation? Now, it says, as we observe the system behavior, the time of the simulation can be compressed or expanded for a speed up or a slowdown of the simulated process. Now, imagine a factory that works. Now, if you really want to understand the manufacturing processes that you observe in this factory, you need to observe it for a long amount of time. For example, at least you need to spend some internship time there, right? Or if there is a simulation model of that factory that performs everything in a computer environment, you can increase the speed of this simulation model and you can make a faster observation just for seeing the main aspects. Okay, for example, what happens if a certain buffer inventory increases too much? I mean, this kind of situation may be observed once or twice a year in that factory. However, in the simulation model, you can increase the speed of the observation and maybe you can experience that problem in a very, very fast manner. Or you can especially slow things down to understand the behavior better. Okay, so there are also some systems which are very fast for human observation, right? So if you really want to understand how it behaves, maybe you need to slow things down. Another advantage is for us to understand the interaction between the system variables. Okay, so in complex systems, we do not really understand the interaction between variables, okay, how they are affecting each other. I mean, for example, in Romania years ago, before the revolution, abortion was forbidden, okay? So when abortion was forbidden, what you expect is an increase in the population, right? So the dictator at that time was also expecting that. So there will be an increase in the population because the abortion is forbidden. Okay, it was prohibited by the laws. However, the effect was not like that. In fact, the rate of young women deaths have increased because of that reason. So because the abortion was prohibited, many women are trying to get abortion processes in non-clinical facilities, unfortunately, and many young women have died because of that reason, and that in fact decreased the rate of births. Okay, so not everything goes as expected, right? So we need to understand the interaction between the system variables in this example. I mean, if you directly apply a law, do you really observe the things to happen as you expect? Actually, that is not the case. But through a simulation process, I mean, before applying such strict laws, maybe a simulation process may help us how it is going to affect the social life. And are we really going to observe the things that we really expect? Okay, and that can only be comprehended by really understanding the interaction between the system variables, and simulation can be a helpful tool to understand that. And another advantage is to learn the importance of system variables on the performance of the system. So which variables are much more important to make improvements? Okay, so you are basically trying to optimize your inventory levels in your supermarket, and you are going to use a simulation methodology to do that. And by the simulation, you can see that by changing which system variables, you can improve the system much better. Okay, for example, by applying which policies on which type of products in the supermarket, you can get a better performance in the inventory costs. So you can understand which variables are much more effective on the system performance. Another advantage is to create a bottleneck analysis, which can be performed to discover which resource is delayed excessively. You know, what is bottleneck? I mean, in manufacturing class, manufacturing processes, or manufacturing planning and control class, maybe you have heard about this term already. What is a bottleneck? Bottleneck is basically the slowest sub-process of a super process. Okay, so imagine we have a long process such as manufacturing in a factory, and bottleneck is basically the slowest machine in that factory, and bottleneck basically determines the speed of the whole system. Okay, the whole system speed is basically binded on the bottleneck of the system. Or imagine you have a congestion on the highway, and another reason for the congestion is the bottlenecks. Okay, and bottlenecks are where in Istanbul, it's on the bridges, right? So as the cars, automobiles go through the toll booths, the bottleneck happens to be there, right? Because they slow down in that part of the highway, and bottleneck is basically the entrance of the bridges. So actually, for these examples, we can easily understand where the bottleneck is. But in a complex manufacturing system, sometimes it may not be easily understood where the bottleneck is. So simulation can help us to identify the bottleneck process so we can improve it to improve the whole manufacturing. And a simulation helps us to understand how the system operates rather than how individuals think the system operates. Now, usually that is the case. I mean, if you ask the people, the observers of a system about the system's behavior, most of the people are going to observe the system superficially, and they are not going to examine what really is going on there. Okay? But with a simulation model where we create every component of the system individually and then combine their effects on each other, then we can really understand how the system operates. Okay? So there is actually a system that operates, and there is a perception of the people about how that system operates. But that perception may not be true all the time. So by creating a simulation model, we can improve our perception about the original system to understand how it really behaves. And one final thing, which we have explained in the beginning, we can answer the what if questions when we intend to design a new system. As I have said, what if we construct a new entrance to our warehouse? What happens to the performance of the warehouse operations? So we can answer this question without actually really constructing this new entrance. We can simply try it on a simulation model.